Thank you. And I think I have some slides, and I will try this clicker. Okay, it works. Hi, I'm Jeff. It's great to be here. I was eating lunch, minding my own business, and Phil came up and said, hey, we have a talk slot open. Do you want to give a talk? And so here I am. Some coworkers put together these slides, and I haven't seen them yet. So if I stumble through things, you'll have to forgive me. I also have a really dry sense of humor, so if I say something you think I'm trying to be funny, then laugh as much as you're comfortable laughing at it, so that I don't feel stupid. But yeah, let's talk about monorepos, and I'll go quickly. First off, I want to plug this site that we made called monorepo.tools. We worked with, so we make a monorepo tool called NX, but there are other cool tools in the ecosystem, and we collaborated with some of the people working on those tools to talk about our different philosophies, some of the philosophies we have in common about monorepos, and then some of the differences in our approaches to this interesting space. So I'd encourage you to check that out. I think it's pretty cool, and you can learn a little bit more about monorepos. So I want to talk about a little bit about the history of how we organize our code, and then talk more specifically about why monorepos are a good thing, and you should think about them, and what it actually means, how you can define a monorepo more loosely, and then talk about how it can make you build better applications and have a better time building those applications. So back in 2005, who's been coding since 2005 or programming? Okay, good. Me too. Back then, I remember we had a lot of, SVN was kind of the big thing. We had different version control systems, but trunk-based development was pretty popular. We had these big trunks where we had basically everything as part of our product that we could fit in one repo that would have no branches a lot of the time and everything in one space. But it was pretty nasty. It was pretty monolithic and pretty anarchic in the bad way, not the good kind of anarchy. And so we had these poorly defined boundaries between code. There wasn't clear ownership of who owns what parts of the code base. It led to lots of dysfunction, led to lots of frustration of people trying to just do their work, but other people getting in their way. And so some things happened, particularly in the JavaScript community and the web development community, that changed how we organized our code. So one is the rising popularity of automation and continuous integration and continuous delivery. This helped increase the quality of our software. We caught more things earlier on in the dev process when they were the easiest to fix. But we had these new problems to deal with that we couldn't just review a pull request and merge it and wait for someone else to find out it was broken later. We were finding these things up front, but it came at the cost of build times and test times and things that would block us from being able to quickly merge code and move on to the next thing. So we'll get back to that in a little bit. And then Git and GitHub. So this lightweight, decentralized version control system came about, and a site that made it really easy to make these. If Tom Teston-Warner is still here, shout out to him for changing the way that we organize our code. But so because of this, we could easily spin up new repositories, split things up more easily so that we didn't have a single trunk that we had to depend on. And the third thing that really changed it was, especially in the JavaScript community, was NPM and semver. So because of semver, we could have this kind of lightweight contract between projects in our ecosystem. Even if they're in different repositories, we could know when I can safely update because it's just minor fixes or minor changes, or when there are major versions so I could plan better. I didn't have to talk to these teams so much. I could see, based on the version of their package, when I should update it. So this also made it where we could more easily separate our code bases into smaller units. And so they led to a massive shift in how teams organize code, which I call polyrepos. And your code would look like this. If you have multiple apps, then you would create large repositories of shared code. And this enabled some good things. It enabled team autonomy being the biggest thing. A team could focus on just their thing that they own, and occasionally it contribute to other repositories and consume other repositories, but spend most of their time focusing on one thing and not getting too caught up with whatever other drama other teams are dealing with. But they came with some costs. So a big one is that you integrate things later. So if you're using semver and teams get to choose when they're upgrading their dependencies, then they're integrating via NPM at some later point. There's a high setup overhead per repository. You have to set up your own docs, your own publishing, your own CI if you're doing that, your own processes. And so that made it harder to contribute across repositories or even to create new repositories for shared things when I should be creating a shared thing. And it led to an overall complexity increase because versioning adds a whole nother dimension of integration across repositories. It has benefits, but it does have costs. And so some of the outcomes were, because of the cost of creating new repositories, there's a lot of duplication of code, of things that I don't want to go through the effort of saying this new button or this design library or this API interface should be its own library or its own repository, because I don't want to have to set up all those things. I don't want to have to agree with all these teams on creating a shared repository. I'm just going to do it myself because I've got to ship things and don't want to deal with that. This leads to inconsistency of user experience and UI across teams, as well as all the inefficiencies that come with duplicating and maintaining the same thing n number of times for how many people have re-implemented it. And naturally leads to organizational silos. You do what you do in your repository, you don't really care about what's happening in other repositories, so you miss out on a lot of collaboration. But some things have changed that are moving us back toward monorepos, but in a way that solves some of the pains that drove people away from monorepos in the first place. Teams want to collaborate more. Product owners want more consistency in their products. And tooling like NX and other tools have made it where the pains of working in a monorepo are a lot lower than they were before. So there are a few really interesting tools in the space, I want to call it here. I'm focusing on NX, which of course is the best. We also have Lerna, which we maintain now. Did anyone know that we took over maintaining? Anyone not know Lerna was being maintained by us? Okay, good. All right. Yeah. So people, we took over Lerna project from the other maintainers who wanted to move on. We made it faster. We've just been taking care of a lot of outstanding issues with it. If you're using Lerna, come grab me and I'll help you. I'll talk to you about all the cool new things with it. There's some other great tools too. Turborepo, Bazel. There's also Rush. A lot of people doing interesting things in the space. But I'm going to focus on NX. And NX is the most popular tool. We've got about over 12 million monthly downloads on NPM. It's grown 5x year over year. Thriving community Slack, 1 million installs of our VS Code plugin, about 1 million developers who are working in an NX workspace, and lots of community plugins, and this number is even higher now, but we have a very extensible toolkit that people are building integrations for. This is my pig Cheddar. He's one of my pet pigs. He's my favorite pig. So I'll leave this slide on so you can admire him for a moment. But let's talk about what this has to do with Jamstack. So I think it's helpful to look at where applications fall on these axes. Like one is, you could say like how interactive or how dynamic on one end of the spectrum, how static things are, or how consumption-oriented applications are, how public is the content, how private is the information. On the left side, we have these things like gaming applications, search, which are highly interactive. There's a little bit of public content, some things that are specific to you, that are personalized. My bill pay, my trading, my banking, very private, very interactive. I usually log into those things to do something. I'll see some information. But then on the, and then messaging apps, on the other side, we see things like e-commerce, news sites, where there are definitely interactive components. I'm putting things in my cart, I'm checking out. There's news sites I might interact with. There's media streaming. I think the Jamstack sweet spot is really in this top right quadrant. You can apply anything to Jamstack, but where the values of Jamstack really shine are this area where people want to see things fast. They want to see things fresh. They want to, you as developers want to be able to deploy these things quickly and frequently. And these are things, these three things, and these are my other pigs. That's Charles Jr. He's my original pig. These are Kuni pigs. Anyone know what Kuni pigs are? Any pig fans in the house? Okay, they're a New Zealand breed of pig, but they're really sweet. But I won't talk too much about that since my time's running out. NX can help with these things. And let me talk a little bit about how. The basic building block of NX is a project. And here we see NX's dependency graph analyzer, where I'm looking at an application that has a cart application. It depends on several projects with shared assets. And I can navigate and see how these projects relate to each other. NX knows how these projects are importing from each other and can dynamically draw these boundaries between objects. And we use that to do all sorts of interesting things. So let's say we have a team of these cool people who are building some related apps. One is like it's a pizza delivery app. Then they have an admin that is managing the app, order management, these different libraries that are making up the app. And these all live in a GitHub monorepo. And inside those, as a dependency of these apps, we have all these libraries, and they're doing really interesting things. So we have a CI configuration so that we can test and build these things and deploy them. And if you if you have a naive configuration of a pipeline, you might typically see something like this, where you have several steps where you build things in order. You build the app first, you build the libraries, or like you run the tests after you've built the app. You might deploy it, you might upload your results somewhere. This is kind of a naive way of looking at running builds in a repository. But as time passes and your repository grows, you're going to see more projects added. This is a good thing. And each of those projects have their own tests, their own lints, and some of them are buildable. And as your CI processes start to grow, your pipeline starts to get clogged. It starts to take a long time. And as they grow even more, you've got to build more as part of the application. So even building this app on its own can be a huge task that won't even fit in. Not including all the end-to-end tests. Aren't these animations cool? This is all shout out to Radish on my team who put these together. But you've got these end-to-end tests that are going to take way longer than anything else in your pipeline. So as you grow, the complexity of your workspace grows. More things you add to it, naturally you start to have more pain. Over time, the time it takes to validate your CI, your pull requests, so you can merge them, grows up as the size of your code base grows. But this is obviously not a good long-term solution. And not only the time, but also the complexity. No one understands the pipeline. Things go wrong. Yeah, this is a painful video to watch. I hate watching it, but I'll watch it one more time. There you go. And so how can we do this differently? So one of the things that NX does is since it knows the relationships, the dependency relationships of projects in your code base, it can look at your commits and compare to commits and see which projects you've touched, and then determine what projects are affected by that change based on what depends on it. So in this case, if we touch these two libraries, the form inputs and the icons, we know that our Pizzaroni app and our admin app can be broken by that. So we need to rerun the builds, tests, and lints on those projects. And so our pipeline has already gotten smarter. Instead of rebuilding everything, we can use NX's affected commands to say, okay, tell me the tests that are affected by this change based on comparing with my main branch. Build only what's changed, run the end-to-end test of what's changed, and lint only what's changed and could be affected by that change. So that's a key distinction. We're not just testing the projects that we've touched, but things that could be broken by those projects we touched. And so, but one interesting thing, that's the first layer of defense, is only running the tasks that need to be rerun. But in the case of linting being a good example of something where we need to rerun lint on the projects that are affected, but we might not actually have anything that needs to be relinted in those projects. Just NX is generic that it'll say these are affected, and you can choose to run them. But NX has advanced caching at the task level. So if I say NX lint the icon library, it's actually going to take some inputs, the files that you input, other changes to see, to create a hash that we then store in this local cache directory. That when if you have these affected targets need to be rerun, after you've determined they're affected and need to be rerun, it's going to check the cache to see if a hash for that project already exists. So in this case, we know that these E2E tasks depend on the build of our Pizzaroni app. And, And so we can see how NX behind the scenes, by just running this target E2E affected, it knows that it needs to rerun the build for the Pizzaroni app, it needs to build the shared UI app, it needs to build shared these other projects everything basically needs to be rerun the build shared UI library. But because NX is caching this library, the first time it's run, the first time that the build is run on shared UI, it's cached locally, and then every other instance that's either directly or transitively calling NX build shared UI is going to be able to take advantage of, one, the Pizzaroni app that's already been built, but also the shared UI that's already been built that these projects depend on. See all these hashes. But what is more interesting is we have a cloud product. NX is a totally open source thing, by the way. Our cloud product is a SaaS product that goes along with the NX open source. And what this adds is instead of just having that cache locally, every environment in your workspace, in your infrastructure, can actually read and write from the same environment. So if I have these projects that I've already run locally or my CI is already built before and the hash matches, I can just download it and replay that task from our shared cache on NX Cloud. So all you have to think about to take advantage of all these things is to define clear boundaries, define project boundaries, and NX can understand the relationships between those projects and do these interesting things to make the caching and also distribution of your work a lot more intelligent. And I want to talk a little bit about how we distribute that work. So if we look at our monorepo again, and we see linting, testing, building of all these projects, and of course there's E2E on top of that. In this case, if I'm building this leaf node at the bottom, then these are the affected projects from that. And I can run the lint on this project, and everything else would need to be linted because it's if I'm run the affected lint, it's going to run all these projects. I can actually configure my inputs for that hashing of the lint to say only depend on the files inside the lib or the root ESLint configuration.json. So I don't have to. So when the hash is created for that cache, it doesn't need to take into account other things like have any of its dependent projects changed, because that doesn't really matter for linting. You really do just care about the code. In most cases, you do just care about the code inside the project itself. So doing this, we can tell NX's cache to be smarter and not have to, that it can just replay the lint from all these affected libraries without having to relint those, which the times can add up as your project gets bigger. So if your task graph is flat, everything is dependent on everything else, and everything can be parallelized. Let's look at a couple of examples of how people typically do CI pipelines and how NX can use what it knows about your workspace to be a little bit smarter. So in this case, a lot of times you'll have an agent that's just running builds of your apps or whatever publishable units you have, and then another one that's running linting, and these will run in parallel. But in the case of NX, we can be smart because we can say, we know the order in which things need to be run. We know what builds depend on what other tasks. Why don't we just take agents and commoditize them and say, whenever one agent is done with one job, let's put some more work on it, and let's use what NX knows about the order in which things need to run, the timings of tasks historically, and use the available agent compute to make builds even faster. And so we know that the E2 app depends on the pizza app, depends on these other buildable libraries. And so NX arranges the builds in a way to know that it needs to build those libraries so that they can be built into the app and then be consumed by the Pizzaroni app. But beyond just sharing this in a single agent, sorry, there's so many animations here that there we go. So beyond just sharing these, the outputs of these across a single agent, we can actually share the results across agents using NX's cache. And so it will do the order, it will order things in the most optimal way in order to get all of the agents to be finishing at about the same time. Did I say that Phil just told me I was giving this presentation, so you'll forgive me for stumbling through things, right? Thank you. That was like a self-deprecating joke, so you could laugh at it. Sorry, I'm just going to fast forward because I have less than a minute left. So with the ability to utilize whatever agents you can provide in the most optimal way, using what NX knows about your workspace, you can basically churn up and down the amount of agents that you throw at the problem. If you want If your CI times, if your PR validation time is growing, you can just turn up the agents. You can throw more agents, and NX is still going to leverage to manage your builds across those agents in the most optimal way it can, to where your build times really become a factor of what your longest indivisible task is, or your longest indivisible series of tasks is. So the more you can break your tasks into smaller chunks, the more NX can do smart things with it. And you can also say, if you want to save money on compute and you don't need to get things done as quickly, you can turn down the number of agents. So what this does is allows you to think less about build times, more about you don't have to worry so much about build times and how you design your CI workflow. You can trust NX and you can trust the tools we're using to make it faster if you organize your workspace in a smart way. And so you can deploy faster, you can have more frequent deploys, you can do more work at build time that you might normally do at request time, like pre-rendering is a good example of this, like being able to statically generate your sites. Something that a lot of people don't do because it's so expensive. But using tools that account for that and using NX at the task level to cache that, make it where you can do more things at build time because you're smarter about reducing the amount of work that has to be done and can make a better experience for your dev team and for your users. I'll plug monorepo.tools again. We put a lot of work into that, a lot of other folks have contributed to it. Check it out if you want to learn more about NX and other cool tools in the space. And I'd also encourage you to check out nx.dev to learn more about NX and give it a try. Thank you.